Here I'm using RAPIDMINER using to solve this problem. We all know that RAPIDMINER is one of the famous tool to identify, analyzing and processing and developing the model using a many machine learning algorithms. So I'm using RAPIDMINER here to solve this problem. And about the dataset name is called customer churn prediction. The description, the dataset is contains the basic information about the customer details like customer ID, age, gender, and the usage frequency and number of support call the customer made, the payment delays and subscription types, whether it is a premium or a basic subscription plan, and the contract length, whether it is a 1 month of period of time or a 1 year of period of time, and the total hours the customer spends in the particular platform, and the last interaction the customer made, and the churn. And we are using here a decision tree model to predict the customer churn prediction. Here is the dataset link. I have just opened the Alter AI Studio. Under that, I have already uploaded the dataset in my local repository. Drag the customer churn dataset. This is how my dataset looks like. Here, the customer ID and the age, gender, tenure, usage frequency, and support calls the customer made, and the payment delay, subscription type, contract length, total spend, last interaction, and the churn. Now, let's see how the linear regression works. We have some of the missing values in our data set. So first we handle the missing values. In RAPIDMINER, we are having a option called replace missing values. Just drag them, connect with them, and another one is then since we are using a linear regression. Linear regression is used mostly like a numerical values, but in our data set we are having a nominal values also. So by handling the nominal values, we have a operators called nominal to numerical. Just connect with them. Then after that, choose the select attribute. Connect with them. Here you can choose any one of the attribute or a subset of attributes or any of the attributes in this option. Here I'm choosing all the attributes. Then choose the set role option to set the value of the role. Connect with them. Here we are predicting whether the customer is churn or not. So I'm using an attribute churn, and the target role is label. Apply. Then now we enter into the prediction model. Here we are using a linear regression. So first we split the data. We are splitting the data into the 70:30 ratio. You can also split your 60:40 ratio as your own wish, as your own requirement. Then choose the model. Here I'm using a linear regression, so I'm choosing a linear regression model. Then choose apply model to test the training data. The first 70 goes into the linear regression model. It is called training data, and the another 30% of the data goes into the apply model for testing purpose. Then we are having a performance operator. We are using a regression model, so we are choosing here a performance regression model. Now connect all of these with output. Run the design. This is the output we are getting. This is the churn. This is the prediction value. C1 1.3.99, 0 0.84827. This is not likely so accurate. Here the performance vector is also 0.230. It is comparatively so higher than other prediction model. So here that is why we are going for decision tree model. As we already seen, linear regression is not that much efficient, provides efficiency as we expected. So here we move on here to decision tree. First, drag the dataset. Then here we are having some missing value. For handling the missing values, we have operators called replace missing values. Drag them here, connect with this. Then here we are in decision tree that only handling nominal data. In this particular data set having some of the numerical data, especially in churn column, so we decided to convert numerical into the nominal. So by using an operator called numerical to binomial, we can convert it. Just connect with them and select single, choose that column churn. Then select operator called select attribute. Here I can select all the attribute. If you want to specify the particular attribute like subset, you can drag them here based on your requirement. Here I can use all things. Then set row. Select churn as an attribute and select label, apply. Then for creating a model, first we want to split the data. So by dragging the split data here, operator here, I'm using a 70-30 ratio. You can use 60-40 ratios as you want. Then now choose the decision tree model. Connect with the model. Then choose the apply model. Since I'm using you can use gain ratio, information gain, and accuracy least square. If your value is completely numerical, you must choose a least square. Since I converted into the nominal on my requirement, so I can use here gain ratio, or you can use information gain also. Since I'm using this model, I'm using gain ratio here. Then connect with the apply model. The 70% of the training data goes into the decision tree that can be used in the apply model, and the resultant is used in the apply model. Then the 30% of the split data is also goes into the apply model. Then drag the choose the performance vector, performance operator. Since I'm using a classification, here I'm using performance classification. Connect with them and connect with this output. In the performance operator, you can choose accuracy and whatever you want based on your requirement. Here I'm using accuracy and root mean square error, root relative square error, squared error, correlation. Yeah, that's all. Now run the process. This is how the tree looks. We have a customer ID, support call, total spend. Here we are getting an accuracy of 99.19 and the recall value is 99.229, 99.11, and the class precision values is around 98%. Then the root mean square error is 0.071. Since the linear regression contains 0.230 to 30 root mean square, it is comparatively so higher. Then we came across to the decision tree. The decision tree provides a root mean square of 0.071. It is provides very less amount of root mean square. Then the tree, then the data set, then the example data set churn true, the prediction value is also a true. Here see all the churn is true and the prediction value is also a true. We can check across the false. Since the customer is not churn, it shows a false, and the prediction is also a false. It is more accurate compared to the linear regression models. Then squared error, then the correlation. This is what we get the accuracy of 99.19%. In a RAPIDMINER, we are having a special model called auto model. It is a model we just load the dataset and set the target and select the task and select the model type. It will get a result in just few minutes. We need not to drag and drop the operator as you want and the model we want to choose. That kind of operation we need not to do these kind of things. So in auto model, we can just easily create a model within a few minutes. Let's start to build the operation. First, select the data set, then predict what column you want to predict. Choose this column, churn. Next, if you want to predict into the classification, turn into the classification you want. Then select the input. I choose all the input I need it, so here you can select the model. Here I'm using a decision tree and also a logistic model. Then run. It takes few minutes to develop the model. Now you can see the result. This is how the model looks. The classification errors, the runtimes, and we can directly go into the decision tree. This is the model. This is the simulator we have. Last interaction and the payment delay, subscription type, support calls. Then the performance. As we already see, the decision tree model gives accuracy of 98.2% and the precision is 100% and the recalls and F measures and so on. Chart prediction. This is how the predictions look like. Production model. Then we can go into the logistic model. This is how the model looks. Simulator performance. It provides a 97.8% and the recall precision value is 98.5% and the recall is 96.4%. Production model. Prediction. Left chart. Data. Statistics. Yeah, that's it. As we already seen, first we approach the linear regression. It is not suited for your model. Since it provides a poor accuracy and performance, we move on to the classification model. That is a decision tree. It provides a high interpretability based on tree logic and also provides both numerical and categorical features. And it is also achieved 99.19 accuracy in our studio. So we choose the decision tree here. The process we already seen. This is the data set. This is how the initial model gives a result. Then we move on to the decision tree model. It provides a 99.19 accuracy. Now, how the business impact of customer churn prediction model. We all know that acquiring a new customer is 5 to 7 times more expensive than retaining the existing one. So, by using this customer churn prediction model, we can provides the result of what are the customers needs likely to stop using the product. Based on that, we can provide a better features to increase the retaining the existing one. It helps to early identification of risk customer, data-driven decision-driven making, cost saving and revenue, improved customer retention. As we already said, business impact of customer churn prediction. We all know that acquiring a new customer is 5 to 7 times more expensive than the retaining the existing one. That is why the customer churn prediction model is used to predict where the customer is identically stop using the product. In that particular point of time, we can provide extra features and customization to the users to retain the existing one. How the model helps: yearly identification at the risk customers and making a powerful marketing and support team to provide a better solution for the particular users and the system, and also cost saving and revenue boosting system and improve customer retention. Then we came to the conclusion part. This project of customer churn prediction is used to predict the customer, to identify where the customers is identically lose the interest or stop likely using the product, where we can provide extra features to retain the particular user or a group of user. In linear regression, it is not that much of accuracy as we expected, so we shifted into the decision tree. It provides a 99.19 accuracy in RAPIDMINER Studio. That is more than what we expected. So here we came to the conclusion. Thank you so much.